Bueno, entonces vamos a empezar. Todo el evento se va a llevar a cabo en inglés por consideración con nuestro expositor, que no habla nuestra lengua, entonces cambio en este momento. Good morning, everyone. Thank you for being here. Today, we are going to be listening to the speaker, Graeme Sait, who is going to talk about soil, human, and environmental health and improving food security for Mexico. We invite all our guests to take part in this dialogue with their questions at the end of the presentation. There will be people helping us collect your questions at the sides of the rows. We are pleased to be accompanied today by Juan Carlos Belausteguigoitia. Juan Carlos holds a BS in Economics from the Tecnológico Autónomo de México, ITAM, and a PhD in the same field from the University of Essex. From January 2005 to September 2012, he was the environmental economist for Latin America and the Caribbean at the World Bank. He was also the coordinator for the United Nations Southern Hemisphere Global International Water Assessment. In the academic field, he was professor at Dartmouth College, ITAM, and at the University of California, Berkeley. During the administration of former President Ernesto Zedillo, he was the Undersecretary for Planning at the Ministry of the Environmental and Natural Resources. He is currently the Executive Director of the Mario Molina Center for Strategic Studies on Energy and Environment in Mexico City. Thank you for being here. We also welcome today Arturo Caso. Arturo studied agricultural engineering at the Tecnológico Monterrey in Querétaro. He has an MBA and a PhD in ecology from the Texas A&M University, TAMUC. He has worked in wildlife and its habitat preservation projects in Mexico, as well as in the United States and Tanzania. Arturo Caso worked for 10 years as a research associate and assistant professor in TAMUC. Recently, he started working in Semarnat as a management executive in climate change policies and studies and ecosystems. Thank you for being here. Next, I am honored to present Dr. Anthony Weller. Anthony is a renowned English psychologist. He is a consultant at the highest level for McKinsey, a corporation dedicated to generating consistently superior long-term investment returns for its clients by investing wisely and enhancing value for advisors and stakeholders. He has been psychologist for international head of states, such as former President of the United States, Bill Clinton, and former Prime Minister, Tony Blair. Thank you for being here. And today we have here Graeme Sait. I will do part of the presentation and then Tony Weller will have the second part done for us. So what we know of Graeme Sait is that he's an internationally acclaimed author and educator who co-founded Nutritech Solutions 16 years ago. He has written hundreds of published articles and a popular book named Nutrition Rules. Graeme has formulated many of the soil health and human health products for which NTS is renowned and has developed all the nutrition programs that are the keystones of the proactive management approach. Graeme is also the founder of Radiance Festival, a 6-day wellness conference held between Christmas and New Year in conjunction with the Woodfork Folk Festival. Radiance has attracted 16,000 people only last year. Graeme is a powerful presenter who speaks at the conference and seminars around the globe. His inspiring presentations are often described as life-changing. We would like to thank all the audience for coming here today, and especially our speakers. I will pass the microphone to Dr. Weller, who will finish the presentation for Graeme Sait. Thank you.
Can I use this? Hello? Yeah. Hi, everyone. I'll move forward to make it less formal. there's an interesting saying behind us: humus saves the world. And in a world, what is it saving the world from is really us. So it's saving the world from us. And it's sad to me that we've got to a stage in human evolution whereby the very place that has given birth to us needs saving from us. And it's interesting that the word humus means soil. Soil must be more intelligent than us to save the world from us. There's also another interesting way of looking at this, is that the world doesn't need saving at all, because the world has been here for billions of years. In fact, we need saving. And one of the ways we need saving would be to explore today what makes us come alive. There was a famous quote that says the world doesn't need saving, the world needs people to come alive. And I would suggest today that you really explore in Graeme's talk, what is it that makes you come alive? And then go do that. What is it we can inspire in our children to make them come alive and teach them to go do that? And one of the things I love about Graeme's talk and the work he's doing in the world is that at last we have someone that really knows about the interconnectivity and the relationship between us and all natural systems, and the natural intelligence and underlying harmonies that have been at work for millions and billions of years that actually have given birth to us and everything we do, from the science that we use to grow things, to the great arts, the great poetry. The same intelligence creates a butterfly, and it creates the thought in your head that has got you here today. So what I'm inviting Graeme to Mexico to do is really to bring the enchantment back to our lives through the interconnectivity of our well-being, personal well-being, the well-being of our children, the well-being of the planet, and to show that we can have an influence on that by really looking at the technology that's been around long before us, that exists in all natural systems, and starting to create things, to create our technologies that will actually embody nature itself. And the very essence of that is that we end up with a waste product that generates more life, rather than the waste that we create now that creates deadness and toxicity for the planet. So I'd ask you to listen to this and really discover the interconnectedness and the interrelation between all things, and especially how through improving the health of our soil, we can improve the health of our children, the quality of their lives, and the quality of the future of Mexico. So I invite you to consider the possibility of exploring what I would call the ancient future of Mexico, to bring out all of these old wisdoms, these ancient wisdoms, and the latest in technology and science, and bring them together in a new way that really, really brings our children alive with new possibility. So thank you for being here today.
It's a great pleasure to be here in Mexico. It's my first time in this country. I'm on the midst of a North and South American tour. I left Australia in the midst of a heat wave. It was 42 degrees, and travelled to Canada where it was minus 26. That was the largest change I've ever experienced. And we had a 4-day course in Canada, and then moved on to Boston, and I move on to Brazil and a few other places in this particular tour. I began this journey some 20 years ago with a sort of a life-changing event where my daughter was hit by a car and put into a coma for 3 months, and during that very tortuous time, sitting beside her, at a point where it got quite desperate and they thought that she wouldn't really survive another day, I prayed and promised that if she survived, I'd do something worthwhile. And unusually, an hour later, she came out of the coma. And so I had a sleepless night and came up with the concept of exploring and teaching the links between soil health, human health, and more recently, planetary health. So I tour the world trying to drive home these key factors. What we've seen is a massive explosion sort of an awakening, particularly in the last 2 or 3 years, where there's just a tremendous demand for this information, and we're seeing some wonderful changes. We see things like, for example, the largest supermarket chain in South Africa. The head of that chain attended my course and said, yes, this is how my growers are going to provide food for my supermarket. So he got myself and my team of agronomists to travel to South Africa over a 2-year period and teach all of the Woolworths growers how to produce food, nutrient-dense food with forgotten flavours and without chemicals. And then Woolworths launched what they call Farming for the Future about 18 months ago, and it has been such a success story that I've now been approached by the other 2 major supermarket chains in that country asking me to come and train their growers because they've lost so much market share. So we're seeing big changes. We're seeing people like the Dole Corporation, who are the world's largest food producers, have recently decided that they want to be trained and to move down this path. And so I'm heading to train some of the Dole Corporation people, and they've become our distributors now as of March in the US. We're seeing things like the largest agricultural company in Vietnam has been trialling in depth this nutrition farming program and decided that they're heading down this pathway, and I've contractually committed to train all 2,004 of their agronomists. So what we're going to begin with today is part of my TED talk that about 6 or 8 months ago I was asked to do a TED talk, and I was debating what story would be most appropriate for my 18 minutes on the TED stage. And just prior to that time, I was asked to speak at a climate change conference on the steps of City Hall in LA. And following that conference, I was flooded with people asking me, what was that word? And I immediately assumed they were talking about a word called mycorrhizal. And we'll talk about this wonderful creature, this most important creature at this point in time, called mycorrhizal fungi. But it's a really hard word to spell, but that wasn't the word. The word was humus. Some of them said, oh, that's a chickpea dip, isn't it? And I said, no, that's not what humus is, that's humus. But that was the key for me to choose this subject. And so, you know, here's people who are felt so strongly about the need to protest against the lack of action over climate change, and yet they don't understand the single most important factor in that entire story. And so that was the reason I chose this subject. And to begin, we'll talk about what is humus. So humus is this chocolate brown substance that's produced by microorganisms in the soil, and it is the essence of soil fertility, and it is their home base. It's ironically, if we look at the derivation of that word, we find that the word humus and the word human mean the same thing. They mean of and for the earth. And interestingly, the word humility means exactly the same thing. And ironically, it's actually our lack of humility that has brought us to the position that we're in. This concept that we can master nature. The definition of the word science in Webster's dictionary is adherence to natural laws and principles. And much of what we've done in the name of medical science, veterinary science, and agriculture science has neglected that basic concept. So humus is the glue that determines whether our soils run brown following a rainstorm event. Humus is the glue that determines whether or not dust storms strip our veil of precious topsoil. So what we can see here, if you can just see it through the dust storm, is Sydney Opera House. The entire coast, some 4,000 miles of coastline in Australia recently was coated in one massive dust storm, and dust storms are about a loss of the soil glue humus. So humus is the storage system for 3 very important substances: carbon, water, and minerals. And this trio will have and is having a massive impact on soil, plant, animal, human, and planetary health. So as part of this presentation and the research for the TED presentation, I went back to look at the papers and the most recent science relative to global warming, and at times, in fact on several occasions, I found myself in tears reviewing that science in recognition that the main word that's now used when we talk about climate change science is the word irreversibility. The whole debate is wrapped around whether we're locked into 3, 4, 5 or 6 degrees increase in temperature. But at some point, someone needs to tell someone that 5.5 degrees is beyond human adaptability. I saw a television program in Australia recently where they talked about the loss of our iconic creatures like the koala and so forth at 5.5 degrees. Well, we're really not going to care at that point because we're not here either at 5.5 degrees. We've seen at this point 1 degree. In our country, we've seen 2 summers of the hottest summers in recorded history. We've just broken all sorts of records in the last 2 weeks in Australia. We've seen the largest drought in New Zealand last summer. We've seen the coldest March in German history. We've seen hundreds of these events from an increase of just 1 degree. Now, 2 degrees isn't double 1 degrees. This is an exponential thing, and we really don't know what 2 degrees looks like. So, I'll just keep moving here. One of the other aspects of the most recent science is this very latest suggestion that by 2017, for the first time in 3 million years, it's predicted that there will be no Arctic ice in summer. Now, this has a massive impact upon what's called the albedo effect, which is the reflectivity of those oceans, and so we are about to see a heating of those oceans beyond anything that we've measured previously. And this is quite serious in terms of massive reserves of carbon and methane that are stored as mountains of this sludge material beneath the ocean. They stay stable at depths of 500 meters, and the ocean is beginning to warm. It's the cold and the pressure at that depth that keeps them stable, and we're starting to see this change at those depths. And without the Arctic ice, there are some serious questions. Scientists working, and you can actually see some of this on YouTube, scientists now working in that region are talking about methane vents that were 1 kilometre long that are now 150 kilometres long, and as far as the eye can see, the ocean is bubbling methane. The July edition of Nature magazine, we're talking about a really prestigious scientific journal, reported a dramatically increased likelihood of a 50 gigaton burp of methane from this region. Just so you understand what that means, methane is 23 times more thickening than CO2 of the blanket of greenhouse gases that traps the heat and warms the climate. And currently, from all of mankind's activities, industrial activities, since 1860, we've seen 250 gigatons of CO2 that's been added to that blanket. Now, if we look at the contribution from farming, we find that 476 gigatons used to be humus in the soil and is now CO2 in the atmosphere. We lost 2/3 of our humus in that period, and we need to understand here the concept of the carbon cycle and recognise that we can't make more carbon molecules. We've only got what we always had, and it's stored either in the soil as humus or in all of the organic matter and carbon-based life forms on the planet, or it stores in the atmosphere, and that's the carbon cycle that we're talking about. And the story here is that the great deal of what used to be in the soil is now in the atmosphere. So this potential burp of methane is equivalent to 1,000 gigatons. So that's more than the total combination of everything to this date in quite a short period. And of course, in that instance, rapid acceleration of climate change is absolutely inevitable. And when we look at that timeline, it is really quite frightening. When we look at the predictions and how quickly they've changed, we see, for example, in 2007, the IPCC predicted a 1 degree increase by 2100. By 2008, that prediction was increased to 2 degrees centigrade. By 2010, the UN Environmental Programme was now talking 5 degrees increase by 2050. 2012, the International Energy Agency now claiming a 3.5 degree increase by 2035, just 21 years' time. And it's every year we're seeing a stepping up. It's part of what we call positive feedback in climate change, the vicious cycle that develops as this thing progresses. And we really, to be honest, don't have an accurate time frame. One thing we are seeing, 250 million years ago, it was actually a methane-fueled extinction that resulted in the loss of 95% of all species. It's now considered that we're in the midst of the 6th mass extinction. We are losing, and I was shocked to find this in recent research. I don't really know what I assumed. I thought maybe 100 creatures a month but to see we are losing currently 150 to 200 species every day of the week was something of a shock, and recognition that this loss of species, this great dying, this sixth mass extinction is happening much more rapidly in the face of climate change. So these things are of massive magnitude, but there is actually something almost more serious than that, and that relates to the ocean. So we saw people like James Lovelock, who came up with the concept, the theory of the ocean, the planet as an integrated organism. And as part of Lovelock's theory, we see that really it is pretty much how it works. We see that the ocean has actually absorbed over half of the man-made CO2 over the last 150 years, particularly since 1950, where we've seen a huge increase in everything. The explosion, the cheap oil-fueled post-war party that has really changed things dramatically in this last 60 years. And it's lucky the ocean did sort of try and balance the equation by sucking in that CO2, but the problem here is that CO2 in the ocean converts to carbonic acid, and that's created an ocean that's a third more acidic than it's ever been in terms of what we understand. So what we're looking at in that equation is creatures that build their outer shell wall from calcium can't do so in increasingly acid conditions. We're talking about shellfish, we're talking coral reefs, we're talking about algae and krill, and quite a number of phytoplankton. Now, there's a few things you need to know here in relation to this. There are 500 million people whose lives are completely dependent upon coral reefs. We're not talking about just the occasional fish meal, we're talking about their lives. Algae and krill are the basis of life in the ocean as we know it. It's hard to even conceive of an ocean life without them. They're the building block for everything. And phytoplankton produce 60% of the oxygen that we breathe, and we've already lost 40% of them to this climate change phenomenon. So it's serious, almost beyond belief. And what most people do when they recognise the severity, here's an idea just for a time frame, understanding in terms of the urgency, and what this talk is a call to action and a recognition that there is no place at all at this point in time for apathy. Now, most people would agree that Dr. James Hansen, the NASA scientist in his late 70s, who's worked in climate change for almost 50 years, is in the top 5 world experts on climate change. Michael Oppenheimer, who's a much published author of climate change studies, says of James Hansen, his science is impeccable. His prescience is unparalleled. We're talking about a guy who has not actually ever been wrong in any prediction to this point. And James Hansen is telling us, and he told us this 1 year ago, that we have just 5 years to make major changes, or we're set to live in a world that is not quite what we would have hoped. There is a desperation and an urgent need to make some major changes. So the message that I'm going to share with you today is this basic concept that we lost 2/3 of our humus, and that massive amount, that 476 gigatons, is now up in the atmosphere. And when we do the sums, we find that it's actually the major contributor to the 120 parts per million that we've got extra of CO2 in the atmosphere that hasn't been there previously. We know that it's cyclical. We know from ice core sampling, and we've gone back 600,000 years, that there's a 100,000 year spike every 100,000 years, as James Lovelock tells us, as if the planet is working in concert, and it certainly seems to be. And we know that we peaked out every 100,000 years for the last 6. We peaked out at 284 parts per million of CO2. Currently, as of about 3 months ago, we hit 400 parts per million and rising quickly. So the thing to understand is that a great deal of what's up there came from the soil, and what I'm about to try and convince you is that the major strategy to change that equation is to put it back in the soil as humus. We need to return it, that carbon back to the soil as a matter of desperation. So as I mentioned, many people would sort of shut down in the face of that enormity, but there's many things that each of us can do from an individual perspective. We're going to talk about some of the individual planet-saving strategies that each of us can contribute to trying to solve this problem. The first of those is a recognition that your wallet is a major tool for change. How you spend your consumer dollar, particularly in the field of food, is a huge player in directing change. Now, I can tell you we work in 46 countries with teams of agronomists. We've tested thousands, tens of thousands of soils and plant tissue from those countries. And those that are practicing organic, regenerative, biological, there are various terms for this natural farming approach. But those that are practicing it, we know from thousands of soil tests, are building humus according to their organic matter levels in their soils on a yearly basis. Those practicing extractive, industrial, chemical agriculture, and we're looking at working with many of them as well, are losing humus on a regular basis. So our role as a consumer becomes selecting food from those who are doing the right thing. There's been an explosion globally of farmers markets, for example. We see in Japan a cooperative between supermarkets between farmers and consumers directly with a supermarket chain of cooperative of farmers with no middleman. And that concept is based upon the concept of putting a face to your food. And that simple putting a face to your food things should become your initiative when you're buying your food. How was that food produced? You talk to the farmer at the farmers markets or however you're going to buy your food. And the wallet drives the change, and we've seen that all over the world, as I mentioned. We need to pay carbon credits to primary producers for building humus. We need to motivate this most important profession, food production. There is no more important profession than food producers. They're doing it hard, they're struggling in the face of extreme weather events, and we need to motivate them to begin the kind of changes that are required to build humus rather than lose humus. And that involves carbon credits, where they're paid for every 0.1 or 0.15% of organic matter increase, and many countries are on the point of adopting that, but we need to do it quite quickly, and we need to lobby to make sure that happens in the short term rather than the long term, because we don't have much time to play with. Composting becomes the mantra for everyone. Every city council, every farmer, every home gardener begins to look at everything that can possibly be composting. We're talking now about compost being, of course, a stabilised form of carbon. So instead of losing that carbon as CO2, we've stabilised it, and when we apply that compost to our soils, we see this triggering mechanism where more carbon is built, because we stimulate the creatures that build carbon in the soil, and there are many papers that basically demonstrate this phenomenon. So what we're looking at up here, if you can see it, is, for example, Auckland City Council in New Zealand. And here we have just 1.5 million people, but half of the waste is taken to one plant by one organisation who turn it with the use of worms to make a product called vermicompost. And vermicompost, research-wise, is about 20 times more potent for use in the field, for use for food production, and to generate more life in the soil. It's about 20 times more potent than any other form of compost. So it can be done on a huge scale, as we see, and the people who've learnt that technology and developed that technology are prepared to share it with anyone, anywhere, because they recognise the importance of that technology at this point in time. We need to inoculate our soils with humus-building organisms. We're going to talk now about the single most important organism on the planet in this point in time. And you're thinking, well, that's me, isn't it? No, it's not. The creature we're talking about is a creature called mycorrhizal fungi. So here we have this little creature that burrows into the plant root and then expands out and becomes this root extension that gives you a 10-fold increase in everything that the root does, which is an amazing phenomenon. So this creature will mine minerals that are difficult to access, like phosphorus and zinc. It will hold moisture in this massive increase of little filaments. It will produce a whole range of biochemicals that stimulate the plant's immune system and protects from things like root knot nematodes and a whole range of other diseases. But most importantly, this creature produces a sticky carbon-based substance called glomalin. Now, this was only discovered by a woman called Dr. Sarah Wright in 1996, but since that time we've discovered that this sticky substance is the triggering mechanism for 30% of all of the humus in the soil. So one creature, 30% of the largest repository for carbon on the planet. There is far more carbon in the soil than in the biomass or the atmosphere, and 30% of that is one creature. Now, the bad news, that one creature is down to 10% of what it was some 50 years ago. We've lost 90% of this critically important creature. The good news is that it can be repopulated, it can be re-inoculated very inexpensively. $5 to $10 an acre can give you a repopulation of those creatures, but we can bring them back. We have to then recognise we've got to protect the creatures we've just brought back. We need to legislate to protect those organisms. Why have we lost 90% of the creatures? And when we look a little more closely, we find that some of the herbicides actually kill these fungi more efficiently than what they kill plants. We find that obviously some of the fungicides are questionable, not all of them, but some of them. We find that nematicides, which is a very commonly used chemical, kills every mycorrhizal fungi every time that those chemicals are used. So obviously we need to change that. We need to legislate to protect the most important creatures as we add them back to our soil. Now there's a picture of grazing up here, and this refers to something that I would direct you to in relation to livestock grazing, and that's the work of a guy called Alan Savory. His YouTube clip has currently gone viral, and Alan Savory speaks about taking areas of desertification, which is a huge percentage of the planet, and using large numbers of livestock to change that equation. And he's been doing this for several decades with great success, as have people globally, in recognition that using livestock and grazing them intelligently, which is really cell grazing, bringing them in for a short time to one area, is not new. None of these ideas are new. This is really the concept of what nature's about, what science is about, adherence to natural laws and principles. If we look at the most productive soils in the history of mankind, we find that they were the Great Plains in the US, which outproduced in terms of biomass any other soil ever for thousands upon thousands of years. And how did that work? And when we look at that equation, we see it was the buffalo and the massive herds of buffalo that were brought into an area for a short time. They stayed there for a day, dropping huge amounts of urine and dung to stimulate the microbiology, breaking off a few parts of that of those native grasses that then could be converted to humus, making a seed bed with their hooves and moving on after a day and returning perhaps a month, 6 weeks later, never grazing below 4 inches. And that is the whole essence of how this concept works. The solar panel and the roots, the leaf that we call the solar panel and the roots are directly interrelated. If we graze back to here, the roots come back to here. The production of sugars via photosynthesis are pumped down to the soil, and that's the principal way that we build humus in the soil, and we can't build humus with no solar panel. So it's a very simple concept that works very, very well, and we need to almost legislate for the use of cell grazing and the use of livestock, because it's also been shown by Dr. Christine Jones in our country to be the premier way to build humus in a short time, the use of livestock to create that equation. We need to stop the burning of crop residues almost immediately. In our country, the whole of Queensland is burned with sugarcane up one whole side of the coast, and that is not acceptable. That's material that should have been converted back to humus. That's soil, that's food for the soil life that we wasted, and the little particles that come up, which is called particulation, of the particles of ash that emerge from a hot fire, that's the minerals you grew the crop with. If you take 100 kilos of plant matter and burn it, you get 5 kilos of ash, and that ash is the minerals that grew that crop, and you just lost your minerals to the neighbouring town. It's not sensible. If they can't learn that themselves, we have to legislate to change that, and we need to do these things quickly. We need to introduce a carbon source with every fertiliser. That might be compost, it might be molasses, it might be a very valuable material called humates. The reason for that is to analyse how did we lose 2/3 of our humus, and we discover that it's linked to soil biology. We discover that the most abundant organism in the soil, bacteria, 500,000 on a pinhead, they're so small, and yet the equivalent of 10 cows per hectare in weight, this invisible livestock beneath the soil, and we see that they have a carbon to nitrogen ratio of just 5 to 1. It means their little tiny body is 17% nitrogen, and when we feed nitrogen, they go ballistic. They go into a feeding frenzy, and now, after their feed of nitrogen, they have to balance out this 5 to 1 carbon to nitrogen ratio. They have to have some carbon. In the absence of carbon with the fertilisers, they have no choice but to literally eat themselves out of house and home. They have to turn on the humus and consume some of that humus to satisfy their need for carbon. And that is one of the principal ways in which we've lost so much of our humus. Some of it oxidizes. Humus is the only thing that stores all minerals in the soil, and we lose some of those minerals. Actually, we thought it was the nitrogen that gave us that response. It was actually the minerals that were released from the humus that contributed to that response from the nitrogen fertilizer, and we need to recognize that and change. This is a little island called Norfolk Island in the Pacific where I've taught the whole island how to produce sustainably. All the farmers grow with this approach, and it's become a showpiece for wonderful, unforgettable food grown in mineralized living soils. And this was a home garden show that I'm trying to teach the locals, that a home garden is your ultimate wellness tool. There is nothing more important for your health than being able to access nutrient-dense vegetables that you've grown yourself with no chemical contamination. And so we taught them how to dig up their lawn and test it for how much calcium was required. The starting point for any fertility program is calcium. To introduce some compost, to treat all the seeds with mycorrhizal fungi, to introduce these wonderful natural acids called humic acid and fulvic acid, and some mineralisation. We know the minerals that are lacking in these soils. And just 4 weeks later, we have this wonderful food, a kilo per bean on these bush beans, and not a mark on anything, a graphic example of this nutrition farming approach. The ninth of the things that we're talking about in terms of how we can be involved in change doesn't involve the soil. It actually involves a recognition of where we can get funds to change things quickly. And so this involves an idea from a guy called Dr. John Hewson, who's an ex-Liberal Party head from Australia. And he's recognised the urgency of the climate change story, and he's recognised that we need a lot of money to induce changes in this short 5-year period. And he's saying, well, obviously one of the great sources of finance is our money for our future, which is our pension funds or our superannuation funds. And so he looked at how we're spending and investing our superannuation funds in recognition of the carbon budget. So I'll just quickly explain what the carbon budget. The carbon budget has been put together by the 2,500 scientists from the IPCC. Most people don't even seem to be aware of it, so they haven't advertised it well, but the carbon budget tells us in no uncertain terms, and no one to this point has been able to refute the science, but it tells us quite clearly that between now and 2030, which isn't a long time, we have to leave, of all the known coal and oil reserves in the soil, we can touch just 20% of them. 80% of them must remain in the soil, or we live in a very different planet that we'd wished we didn't live in. So that's the very simple carbon budget. And in relation to that, recognising, of course, that if we accept that premise, the large companies that are involved in looking for more coal and oil are essentially rogue companies that are wrecking our future. So where are we investing, John wondered, our money for the future, our money for our future? And he discovered that 55% of that was invested into the BHPs and the Woodside Petroleums and companies looking for more coal and oil, and certainly burning as much of what they've got that they possibly can. And then he looked at how much was involved in renewable energy, understanding that energy is how we produce greenhouse gases, and he found just 2% of our money in our future was invested in renewable energy. He set about a little trial just with state government employees in one state in Australia where they got an opportunity to tick the box when they got their pension fund report, and they said, do I want my money invested in renewable or non-renewable energy? And that turned 2% into 10% without any education as why you'd tick which box, and that provided $400 million just in that tiny little example of superannuation funds that could be directed towards renewable energy. So we're going to talk about the win-win scenario if we do begin to build humus in our soils. Our National Bank in Australia recently said, okay, we're lending farmers money constantly to buy their neighbour's farm, and as part of the mantra that has driven modern agriculture, which is get big or get out. And so we're lending money for farmers, and those loans are falling over, and we need to analyse what determines profitability in agriculture. So with our national research body, the CSIRO, on 800 farms for 3 years, they studied what made you profitable. And to the surprise of everyone, the standout by miles ahead of the second equation, the standout was organic matter. your profitability was totally based upon every 0.1 or 0.15% increase in organic matter was worth a certain increase in your profitability. So that was the first sort of major study into how important humus is in terms of farming profitability. So that's one of the win-win scenarios if we start building humus in our soil. The second one relates to water. Now, as climate change grows, the issues grow. We'll see water is rapidly becoming a precious commodity. There'll be wars fought over water in the future. And when we look at water and the way we manage it currently, it's not very sustainable. We store our water in massive dams in Australia with 45-degree days for weeks on end, massive amounts of evaporation. We've got a big carbon footprint to pump that water from the dams to the farms, and another carbon footprint to pump them out in centre pivots and overhead irrigation where there's more loss through evaporation. And we compare that to building 1% humus in our soils, just 1% of this wonderful carbon-based material. And that enables us, that 1%, to store 170,000 litres that we couldn't store before. The tabletop is a square metre, and on that tabletop we can now store 17 litres. 2 big bucketfuls of water could be stored that couldn't be. And this is beneath the soil. There's no evaporation, there's no carbon footprint. The plant takes the moisture as it requires it. That's the perfect system for protection of this all-important precious resource called water. Humus improves the nutritional value of our food. Now, there's some things to understand here. Humus is the only thing in the soil that stores all minerals. It has negative and positively charged sites that store everything. It's the only thing that stores things like sulfur, which is so important for our immune systems, for example. It's the only thing that stores boron, which a lack of boron is linked very strongly to arthritis in communities. So if we have low humus, we're incapable of storing those. But more importantly than storing all minerals, humus is the mechanism by which those minerals are delivered. There is a microorganism behind every mineral, and they live in humus. There are nitrogen-fixing, potassium-fixing organisms, phosphate-solubilizing organisms, manganese-reducing organisms, iron-reducing organisms. Every mineral has a microbe behind it, and humus is the home base for those. The higher we build our humus, the greater the mineral storage and the greater the mineral delivery for the health of every one of us. Humus reduces chemical contamination of our food. We see, working with farmers in 46 countries, that those with the highest levels of humus in their soil have the lowest need for chemical intervention. The lower your humus, the worse the resilience of the plant and the soil, and the more you need to step in with chemicals, of which we will end up with some of those chemicals in our food. We weren't told some of the things we should have been told with this chemical experiment, as I call the last 10 decades in agriculture. It's okay to have done the work and shown that a guinea pig and rat didn't die from a 3-month study, but there were 2 things we forgot. The first of those is called bioaccumulation. We can get away with 5 parts per million perhaps of a chemical like diethane or glyphosate or whatever. I'm just making these figures up, and that didn't kill the rat. But how does the human body manage that chemical was the question that wasn't asked. The principal organ involved in our 2-phase detoxification system is called the liver. The liver is geared to take care of most natural things. Whether it's arsenic or a snake bite, the liver has the mechanisms to detox or begin the detox process, but it has not seen many of the chemicals that we're using in agriculture. And the liver says, what's this stuff? And it pumps it off to keep it as far away from damaging organisms. It pumps it off and stores it in your fat cells. And there it bioaccumulates. And we see the research into US school children where they looked at the 13 most commonly used chemicals in agriculture and the presence in the tissues of those school children. They couldn't find one child who didn't have unacceptable levels, according to FDA standards, of all 13 farm chemicals. So the chemical experiment in agriculture, there's been a huge price to pay for that. The higher your humus levels, the less the need for chemical intervention. Humus cleanses the soil. We see the EPA, if there's a major chemical spill or oil spill, the first thing you bring in are 2 natural substances, humic and fulvic acid, which are naturally found in humus. We look at your own digestive tract, the 30-foot tube that runs from your mouth to your anus that should contain 100 trillion microorganisms. And we find that we hopefully don't pour chlorinated water down our throats onto that life within. because there's 100 trillion organisms responsible for every aspect of your health. Your immune system that determines whether or not you become a grim statistic, 85% of it is located in your gut, trained specifically by that life within, that massive number of organisms. So we hopefully wouldn't drink and pour that chlorine down on this life. We'd pour it through a carbon filter first, and that's exactly what humus is in the soil. It's a carbon filter that isolates chemical residues, that isolates heavy metals to prevent them from affecting plants, animals, and humans. And finally, humus sponsors soil improvement. The most important thing when you're growing crops involves something called gas exchange. Have you got a soil open enough to allow oxygen to diffuse in? The roots and the organisms surrounding the roots use that oxygen, then they breathe out. And that's the CO2 that oozes from the soil. The plant leaf is covered in tiny little pores that suck up that CO2 and combine it with water and sunlight and produce the only source of food on the planet. All of us come from that process called photosynthesis. And how well photosynthesis works is about gas exchange, how well your soil can breathe. And humus is the major component that determines that. We see, for example, in New Zealand, this is the gentleman who's developed the technology to compost on a huge scale using composting worms to do the job. And here's a carrot farm in the height of their drought, and this is a little device called a penetrometer, and this is a big man who couldn't push more than this far into the soil. And here we have the vermicompost, his vermicompost, added to that soil with one short shower in their drought period, and the whole soil structure, all of the lumps have disappeared, and he can push this penetrometer any point where we've put the humus back onto the soil. He can push the penetrometer. That's a soil that can breathe, and that's the most important thing in food production. So humus is this hugely important substance that we've used and abused to the point that we've brought ourselves to the brink. When we build humus in the soil, we are literally stepping into that carbon cycle and sequestering carbon that otherwise would have been in the atmosphere causing the problems. When we build humus in our soils, we improve soil health, we improve plant and animal health. We dramatically improve our management of this precious substance called water. We improve the health of every person eating the food from those soils with less chemical contamination and so forth. Each and every one of us contribute to the change. We need to review the ancient wisdom that defined humus and human as of and for the earth. That's what it means, and so does humility means the same thing. And we see it's, as I said, we need to reclaim the humility to work more closely with the system rather than with nature, rather than against nature. We can all be involved. We can phone our councils, for example, and say, look, we want a separate collection of all organic matter. We don't want to put in with the inorganic matter because that creates massive methane sinks with anaerobic decay, and methane is 23 times more thickening of that blanket, and it's the largest single source. Other rubbishness, we can change that. We ring our councils. We want a separate bin. We want you to compost that, and we'll buy the compost from you. We all get involved in calling our superannuation funds or our pension funds and directing where our money for our future is spent. And we compost. Each and every one of us can be involved in this change, and I hope some of you are motivated to begin doing something about it. That's the first stage of the talk. We're going to now talk about a few other things in terms of drivers of this change. The first of those that's a sort of a dominant kind of belief in modern agriculture is that we've been led to believe that insects and disease would decimate our crops without farm chemicals and decimate our profitability. The reality is that that's not always how we farmed. What we see if we look at it historically, that when we introduce this very simplistic way of feeding our crops using just 3 minerals, understand that every crop, every bit of food that you take from the field contains some of all the 74 minerals that were in that first cell that oozed from the Precambrian ocean. And we, for many decades, we just simplified it down and put 3 minerals in and took 74 of them off, and obviously that had a demineralizing effect that impacted the health of every last one of us. But that also, basically that dumbed down nutrition tended to have this impact of increasing insect and disease pressure, and now we needed to bring in rescue chemicals to save the day. And what we missed here was how insect pressure actually works. And it reverts back to a brilliant sort of world-changing book called Tuning into Nature by a guy called Professor Phil Callaghan. And what Professor Phil Callaghan showed us was that the feelers on insects aren't feelers at all. They're incredibly complex antennae that make a TV aerial look like a little kindergarten toy. And these antennae pick up infrared radiation and other environmental signals. And Phil Callaghan showed that plants emit a steady flow of infrared radiation if they're mineralized and healthy. And if they're filled up with nitrogen, particularly nitrate nitrogen, which always enters the plant with water and dilutes everything else. We've got a watery, demineralized plant. If it's over-applied with nitrate nitrogen, that plant sends out a staccato, tss, 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 and the insect says yes. And then he comes to do his role, because the insect's role in the scheme of the thing is he's the garbage collector. You grow garbage, and the garbage collector arrives to do his job in the scheme of things. So it's a lack of that understanding and a recognition that a healthy, well-balanced plant doesn't attract insects to the same degree. We see that in modern agriculture we've seriously oversupplied nitrate nitrogen. As I mentioned, it's diluted when it's uptaken, and that low Brix, that poor nutrient density becomes a calling card for insects and disease. And the chemical response has now been shown, and there's good research to show that every time we use a fungicide, we actually compromise plant immunity, which of course compounds the problem. We've also seen, in terms of changes and drivers that are changing agriculture, industrial agriculture has been basically a massive replacement of the family farm. And there's serious consequences for the soil, for the people and the planet, because this extractive approach has not had the stewardship that came as a natural part of family farming. And so we're seeing a series of transformations. One of the things that's impacting all of us, and of course agriculture and food production, is this issue of peak oil. And we need to understand that in the history of economics, when a non-renewable resource has reached halfway, and there's been many of that have come before, every time the second half the price rises, rises and rises. And where does that leave food producers when everything in a chemical approach is based upon petrochemicals? The fungicides, the pesticides, the herbicides, the nematicides, the DAP, the MAP, the urea, the diesel, everything. And you are incredibly dependent. So we see smart operators the world over recognizing their vulnerability in the face of peak oil and seeking to reduce their reliance upon petrochemicals. That's one of the drivers that is marking this change. We are what we eat, and what we eat comes from soils that are a shadow of their former self. And we see huge bodies of research now confirming the original statement by the founder of modern medicine, Hippocrates, let your food be your medicine and your medicine be your food. Boy, do we know the truth of that now as the studies pile upon each other relative to the protective capacity of phytonutrients in plants. We need to understand that we can't replace food with supplements. Food, fresh vegetables and fruit, the minerals in that food are 98% bioavailable. That's where we were supposed to get our nutrition. We can go and buy the very best collated supplement in the health food shop, and we're never going to get much more than about 50% bioavailability. We were supposed to get our nutrition from plants, not from the drugstore shelves. Water, we mentioned the story. 74% of the planet's covered by water, just 3% of that's fresh, and 90% of that's used for irrigation. And we mentioned 1% is 170,000 litres per hectare that soil can hold that it couldn't hold previously. But that's just the start of soil, because I didn't give the full story of humus and water, because the organisms that live in humus produce a sticky substance that actually serves to hold moisture dramatically well. We have many, many growers who will phone up after just 6 months of a program and say, my water requirements have dropped 40%, how is this possible? And we find that they're the people who have learned to brew up very inexpensively their own microorganisms and introduce billions of this new life workforce into the soil. And we see these organisms, when they produce this bacterial slime that they produce, that it serves just like water crystals in the soil and dramatically improves the water retaining capacity of that soil. So humus does more than just store moisture, that the organisms living in humus create this wonderful substance that they're looking after their host, the plant. The plant's feeding them on a daily basis. and if they produce this substance, they can hold moisture more effectively. We talked about peak oil. We've got another issue facing agriculture, and I would estimate that perhaps 40% of the so-called experts have agreed that the first half of phosphate, the major part of the NPK equation, phosphorus, about 40% I would estimate of people are saying we've used up our first half. So this is peak phosphorus that's coming, another thing that's going to impact. And what we need to understand is that over 2/3 of all phosphorus that we've used it's been a very inefficient way of phosphate fertiliser, and we've got massive. In Australia, our science body tells us we have $10 billion worth of phosphorus locked up in our soils. Well, the only way to access that frozen reserve in the face of rising prices, which we'll see with phosphorus like we'll see with oil, is to access. And you can only do that with biology. And the more humus you've got, the greater access you have to that whole issue of locked up phosphorus. Biological agriculture is the only way to get back that whole approach. And when we look at the role of nitrogen in the whole global heating equation, we see that agriculture produces 80% of the nitrous oxide emissions, and nitrous oxide is 310 times more thickening of the blanket. So obviously we need to look at our management of nitrogen, and we need to look really hard. And we see that 1 kilogram of nitrogen oversupplied, because we put too much on at the start of a crop, for example, results in the loss of 100 kilograms of soil carbon. We need to rediscover how to get this nitrogen free. There are 5,000 truckloads of nitrogen gas hovering above every hectare. It's the predominant gas in the atmosphere. We need to have simple little changes. Cuba has developed those changes and understood those changes to access nitrogen via nitrogen-fixing organisms. They need to have oxygen. They need to have a little trace mineral called molybdenum. They can't make the enzyme that allows them to fix the gas into ammonium nitrogen without molybdenum to make the nitrogenase enzyme. There's a 5-part recipe that enables that is part and parcel of this biological agriculture approach, this hard science-based approach to grow food. The recent decision, one of the things we're seeing globally, and it's a change that will reach a critical mass at some point, is this growing intolerance of contaminants in our food, this recognition that our children are at risk. The Dole Corporation, when I asked this massive organisation, well, what drove your change to decide that you wanted to become our distributors and you wanted to change the way that you farm on thousands of farms across the planet? And they said, well, our largest suppliers, Walmart, every meeting they say, all we ever hear about, we get these handwritten letters, we hate handwritten letters. Everyone hates handwritten letters. Remember, if you want to instigate change, don't email, write a handwritten letter. It sits in the inbox and you stare at it, and you are much more likely to do something about it if you get a flood of handwritten letters and you're the head of a large corporation or you're a government minister or whatever. And in this case, those letters were from concerned consumers demanding a reduction in chemical contamination of their food. So we're seeing that globally, and this nutrition farming approach, as I've termed it, is all about reducing the need for chemicals. Food security is becoming a huge issue wherever I travel. I had Sheikh Hamad from Qatar, which is the world's richest country, travel to Australia last year just to hear a 2-hour presentation. And he invited me to be part of his 12-man board to try and build their food security. They realise that in uncertain times nothing is more important. They only have 5.5% food security in that country. You can be the richest country in the world, you shut down their food supply and you own them should things revert to those kind of conditions. We see Japan's only got 40% food security. You shut down the Sea of Japan, everyone at the moment is concerned about food security. You need to be able to produce as much, the highest percentage as possible of your own food, and you want that food to be medicinal food with forgotten flavours, and of course there's tremendous value for the health of all of us. One of the things that we're seeing constantly, and I ask farmers in every country, how many of you have still got earthworms remaining in your soil? And 1 hand in 50 rises across the globe, and this recognition now that we've finally got a bit more interest in soil science, and we see this creature as a wonderful, wonderful creature. It has such an impact for all of us in terms of the quality of food that's produced. We see in the soil that it's involved in the aeration, the aggregation of soil particles, the distribution of microbes. It brews its own microbes that you can't find in the soil. They come directly from the earthworm's guts, and they're incredibly important in terms of the delivery of minerals into our food and the protection of plants so they don't require chemical intervention. Basically, if you look at the little poo that comes out their back end, it contains 7 times more phosphorus, 10 times more potassium, 5 times more nitrogen, 3 times more magnesium, and 1.5 times more calcium than the surrounding soil. It's a little fertilizer machine. It's where we were supposed to get nutrition to grow healthy crops. Earthworms have an inbuilt colloid mill that reduces particle size. Suggestions not based on enzymes, it's based upon these organisms that only come from earthworms. And here's the figure. A recent study in Australia showed that earthworm compost was 20 times more efficient than the next best compost, which was compost made from cow manure. And when we look at those figures, if you had 25 earthworms per shovel, which is the holy grail of the nutrition farming approach, so any shovelful, you count them as 25, if you achieve that, and we have many growers who have, then those earthworms are producing 300 tonnes of earthworm castings per hectare. Now, earthworm castings sell for, well, we've said $100, it's really more like $300, but even at $100 per tonne to get earthworm compost, that 300 tonnes is $30,000 worth of free fertiliser. That is obviously the way forward. And when you get to that point, you have a very big smile on your face if you're a farmer, because you don't need any further inputs and you're producing beautiful food for the benefit of all of us. One of the things we find if we want to bring back our earthworms is some of the simple strategies we teach. You can, for some reason, earthworms love a creature in the soil called protozoa, and when we do soil life counts, we find protozoa have been decimated in our soil. You can bring them back really inexpensively. These are ideas that are really quite basic. Protozoa accumulate in alfalfa. They are there in huge numbers. You can actually make what's called an alfalfa tea and have a whole tank full of protozoa, bring them back into your soil, and watch the earthworm numbers grow. It's one of the strategies. You can brew up fungi, which is the second favourite food. You can brew them up for a couple of dollars a hectare and put them out into that soil, and the earthworms arrive from wherever, almost as if by magic. And this is some of the strategies that we teach when we talk about this concept of nutrition farming. We talk about growing a little area on your farm and feeding it up and irrigating it and slashing it and having earthworms boiling in that area and then transporting them to other areas in your farm. When we talk about the earth-changing power of compost and the 5 billion beneficial organisms found in a single teaspoon of that material, and the fact that those organisms have been shown to neutralise pathogens through competition for nutrients and consume competitors and produce inhibitory compounds and stimulate the immune system of the plant. And we've shown that they also stimulate that incredibly important creature called mycorrhizal fungi. So, in conclusion, the extractive industrial approach to agriculture has proven to be unsustainable on every front. The declining nutritional value of the food. We see the World Health Organization in a recent study called Nutrition and Disease. They couldn't find a disease that didn't have a nutrition link. There are nutritionists suggesting that our food contains just 20% of the food found in the food consumed by our grandparents when they were children. So we lost 80% in just 3 generations, and a huge amount of that comes from the mining of our soils with a very simplistic approach to agriculture. So a loss of that nutrient density has compromised our health, along with the chemical contaminants that become an integral part of that loss, because the two are intimately interrelated. So we need to look at changes. We're seeing changes, thankfully, globally, and this nutrition farming approach is a hard science-based solution for these issues. Thank you very much for listening. I'd like to hear any questions if you have them. Thank you.
Thank you so much for your conference. Very interesting. If it's okay with all our students of faculty, we will start by Juan Carlos Belausteguigoitia with his comments.
Bueno, pues primero que nada, agradecer la invitación del ITAM a participar. Tengo que hablar en inglés, ¿verdad? Well, first of all, I would like to thank ITAM for its kind invitation to participate in this event. Secondly, I would like to congratulate Graeme for a very interesting talk. I'm going to comment on it, but with the warning that I'm not a scientist. I'm an economist, and what I will try to do is to provide a kind of framework to understand what Graeme told us in the Mexican context. And something that I don't want to forget is to draw your attention to environmental issues. You are all young, most of you. I saw some colleagues of mine around. I used to be a professor here. But Mexico and the world need young professionals in environmental issues, young environmental economists, young lawyers that know how to craft laws that can balance the environment and economic growth. We need managers that can identify profits in providing the kinds of goods that won't hurt the planet, that will benefit the planet and will satisfy consumers' needs. So it's a very, very fertile arena for young professionals, and I really encourage you to look for opportunities in the market to use your skills in environment-related areas. Well, as I said, I'm not a scientist, but I have some experience about the environment and climate change, agriculture, and so on. And what I do have to say is that I agree with your basic conclusions, that the extractive industry approach to agriculture is not sustainable, and that a loss of nutrients in our food has compromised our health. So what I'm going to do is give you this framework. First, I'm going to talk about the importance of natural capital. I mean, the whole talk was built around humus, which is a form of natural capital. Then I'm going to briefly talk about why agriculture and the decisions of farmers don't produce the social benefits that we all expected from such an important sector. In other words, why with some intervention, with some creative intervention, the decisions of farmers could be improved in the sense that social welfare, global welfare could be improved. And then finally, I'm going to talk about climate change and all these win-win opportunities that can be implemented, especially in the case of Mexico. Well, first, with regard to natural capital, and nature is much more than capital. Capital, as you know, a capital good is an asset. An asset is something that provides you with a flow of income, an income flow. And the interesting thing about national accounts, GDP, and other forms of national accounts is that when this was created, when the national accounts were created, they were thinking about the concept of income in a sustainable way, but they only considered the degradation of one form, or the depreciation of one form of capital. I mean, to produce goods and services, you need natural capital, land, energy, etc. You need human capital, the talent of people and the work of the people, and you need also produced capital, machines, buildings, etc., etc. So when the system of national accounts was created, and to really get at the concept of sustainable income, they realized that when gross income was computed, they had to deduct the amount that the physical capital had depreciated during the production of the goods and services that were produced that year. But they didn't take into account the degradation and the degradation of other forms of capital, for example, the environment. So when we and fortunately we have developed the mechanisms, the methodologies to do that thing. And when we take into account the depreciation, the degradation of natural capital, we realize that what we consider income was in reality not income, but that we were eating up our natural capital. Just to give you an example, briefly, if you have 100 pesos in the bank and you have a 10% rate of interest, then every year you can consider that your income is 10 pesos. But what happens if one year you take the 10 pesos plus 50% of the principal? Can you legitimately say that your income is 60 pesos? Of course not. It's 10 pesos and you ate up 50 pesos of your capital. So when we include the depreciation of natural capital in Mexico, we have to deduct about 10% of GDP per year because of the degradation of natural capital, the degradation and the exhaustion of natural capital. So these figures are really huge. If you consider that, then you can say that the Mexican economy is not in a sustainable path. So what we were considering income, I mean, in the case of the person that used the 50 pesos of the principal and considered income, was in actuality not income, but we were eating up our natural capital. And that's what's happening with oil and with humus or land. So the importance of natural capital. The second thing I want to talk about is about agriculture, and Graeme mentioned that in order to sponsor rapid change, we need to make it financially attractive to do the right thing for farmers. So we must make it in the farmer's own interest to do the right thing. But as things stand now, this clearly is not the case. Most of you, as ITAM students, have studied the market system, and you know that markets fail, and you know the reasons why markets fail, and these reasons are very, very clearly exposed in the case of agriculture. There are many market failures. Examples, quick examples, when farmers introduce pesticides and artificial fertilizers, they not only improve their yield, but they create damage to others downstream, and they also exhaust the productive capacity of the soil. So, and some of these costs are not taken into account by the farmers when they apply these pesticides and fertilizers. But when they only look at the bottom line, at the very, very focused bottom line that they have, it's in their own interest to apply fertilizers or apply pesticides, or even worse than that. If a person owns a plot of land that is forested and wants to build, I don't know, or change the land use and plant corn, then that person doesn't take into account all the benefits that the forest provides society with. So there are many ways in which markets markets fail to induce the right decisions among landowners. The bad thing is that governments have aggravated this fault. Governments, what's the basic policy, agricultural policy of a country like Mexico, and this is repeated all over the world. They provide farmers with subsidies for pesticides and fertilizers. They provide subsidies for land clearing. In Mexico, we used to have something called Compañía Nacional de Desmontes. So whose only goal was to clear land, jungles and forests, so that new farmers could be brought in and plant their crops. So governments traditionally have aggravated the market failures, and the result is the first of Graeme's conclusions. The unsustainability of the extractive industry approach to agriculture. That's very, very clear, not only with regard to soil, but especially in Mexico with regard to water. What's happening in Mexico with regard to water and agriculture is a crime. In the case of water, for example, Mexico, water is not only free for farmers, but we subsidize the electricity to pump out water of the aquifers. And that's resulted in overexploitation of our aquifers, of our most important aquifers. And again, that's how an example, a very clear example of how governments aggravate market failures. With all these subsidies and distortions, 12% of all of the emissions of the Mexican emissions of greenhouse gases come from agriculture, and 6.3% come from land use change. So almost a fifth of the emissions of greenhouse gases in Mexico come from that sector. Very quickly, with regard to climate change, you know, there are two pillars of climate change policy. One is adaptation. Climate change is already here and will be aggravated in the next year, so we have to adapt and we have to cope with it. And then there is mitigation. How can we stem the growth of greenhouse gas emissions so that climate change doesn't get as bad as it could be, catastrophically bad, I mean. The recommendations, the policies that Graeme was describing have part of adaptation and part of mitigation, most of them. But the important thing is, what should Mexico do with regard to adaptation and mitigation? With regard to adaptation, it's very important that Mexico should first identify the risks. Mexico is one of the most vulnerable countries to extreme meteorological events. Most recently, in September of last year, we saw the floodings in many parts of the country. The cost was close to $7 billion. It's we cannot attribute the floodings to climate change, but what we do know is that events like those we had in September will be much more common in the future. So we have to adapt, and we have to make sure that all these risks are included in the oh God. Agua tienen, perdón. In the decision-making process. So, for example, we must make roads that are better prepared to deal with such events. We must make electricity plants and distribution lines that are equipped to deal with those problems, pipelines, etc., etc. With regard to mitigation, the key characteristic of of climate change is that we are talking about a global bad, and that again, given that most of you have taken Economics 101, you know that the two characteristics that describe a public good or a public bad are non-rivalry and non-excludability. And that means that if there's no coordination among all the participants, if one participant doesn't do what it's supposed to do, he or she can still enjoy the benefits of the coordinated action. And that means that no single country has the incentive to act on its own. So what should Mexico do in a situation where there is no international or global agreement that is verifiable and where we can be sure that everybody is doing what it's supposed to be doing. So Mexico should undertake only win-win actions. And the very interesting thing about Graeme's presentation is that it provides us with a lot of win-win actions. What's a win-win action? That regardless of what happens with anything else, it's in our interest to undertake those actions. And two of the actions that I been doing research on and I fully support are the expansion of our renewable energy base and, of course, the increasing water efficiency. And we are at the Center doing a lot of work on both these issues. You are welcome to call us, to visit our webpage, and you'll see all the things that we are doing in that regard. I think this is all I have to say. And again, thank you for the invitation and congratulations for a very interesting presentation. Thank you.
Dr. Sait, it's a very honor to have you here. I haven't met you before, but I have seen some of your presentations on YouTube. I'm also very happy to be here. I'm here because first of all, I want to give you the apology from my boss, that is the Sub-Minister of Environmental and Natural Resources from the Ministry of Environmental and Natural Resources, Mr. Lassie. He couldn't come, and that's why I'm here. But anyway, I want to tell you that Mexico is an underdeveloped country that needs food, need to produce food. We cannot say that if we are affecting the environment, we should not produce food, you know. So that's why even the minister, Mr. Guerra Bud, has said that we need to find a way to produce food, but also to protect the environment. So all your ideas that you are expressing in this conference are great, and I think we should try to implement here in Mexico. And I also want to mention that Mexico and England are the only countries that have a climate change law. And in Mexico, in the Mexican one, there are two articles that, the 29 and 77, that cover what we should do with our soil. That is to construct, to protect, and to try to have always organic matter. But also what this article said is that we need to also have a way to measure the organic matter that is in the soil, so we can know how are we improving our, with the management that we are planning to do for our soil. So probably, and you have seen this in other countries, our goal is not to convince the governments, but I think the most important thing is to convince the agriculture people or the cattle people. So yeah, because for them, maybe for them it will not be such an important thing to tell them that 1 degree of temperature will increase or 5 degrees in 5 years or else. For them it's like they don't see what is really happening. But as you said, if we can give them some economic incentives, like could be the carbon bonus, or tells them that actually if they have humus in their soil, they can be better producers. I think that's the key. They need to see actually how their crops are improving, And then they will stop buying any fertilizers or pesticides if they can see that these other things work. So I remember, I got my bachelor degree in '87 here in Querétaro, Mexico. And I remember that I was taught to actually use urea as the nitrogen source. I remember seeing the crops like it has been snowing, white of urea. And actually we fed some of the cattle with urea actually to improve the protein level in the ration. Now I know that this is changing, and actually some cattlemen are trying to be more, to affect less the environment. And so at this moment, the ministry where I'm working with is also talking with another ministry that is the Secretariat of Cattle and Fisheries, SAGARPA. And we are in the process of signing an agreement that also including local producers and cattlemen, to try to increase the organic matter in the soils. So they are, as I said, they are looking for some incentives, economic incentives as carbon bonus, but they have said they already, some of them have been trying to get these incentives for more than 10 years, and they have said that the protocol of Kyoto is sometimes very difficult to have all the rules, to cover all the rules. So what the government is studying is to have a local protocol to try to adapt it to Mexican conditions. And now what they want is to increase the organic matter for 1% per year. 0.1% per year, and in 10 years will be 1%. That's the goal of this program. So probably in April, we will sign this agreement with the two ministries and the local producers. So I would like to finish with two questions. First, I would like to say that Mexico has 54% of arid zones naturally. And besides that, we have about 80% of erosion caused by humans. So the idea is to try to help those areas, those arid zones. And, I have the opportunity some years ago to go to Australia, your country, but I went to the Northern Territory, that is very beautiful, by the way, but this is forest. But I know that Australia has big extensions of arid zones where they have these sheep farms or sheep ranches, I don't know how you call them. And I don't know if if this program of trying to increase the humus in soil has been adapted to these extensions of land, to ranches, not just agriculture, but to extensive ranches. I don't know if this has been done in Australia or maybe South Africa, where you have been working. And the other question is, if we go to the south part of Mexico, we have the same problem as is in the Amazon in Brazil, where the tropical forest has, the rainforest has a very, very low, we are talking about 10 centimeters of humus there. When the rainforest is there is a cycle, an active cycle of organic matter and going up and down, and that's also helping because of the precipitation and the temperature. But we have lost some of that rainforest because of people clearing that rainforest, and also because some of the fire, forest fires. And I don't know if your program could be implemented in those areas that humus has been lost because after the jungle is gone, then because of the wind and also because of precipitation, there's a big erosion, and we have lost already that. I don't know if we can use that. You mentioned this humantis, you know, and how expensive it is to use in arid zones and also in those tropical areas that we have lost already. So that's it. Thank you.
Okay, thank you. Thanks. In answer to your question, there are very large areas now in Australia that have practiced what's called holistic resource management. In fact, with all of the benchmarking of carbon, it has been determined that that particular approach, which is really the cell grazing concept, this recognition that you really have to, it was really what we learned from the Great Plains, that we really need to have a solar panel that is producing glucose and pumping some of that down to the roots, some of which is turning into humus, and you lose that completely when you trim right back down to a bowling green. So that concept has been practiced for some very, very large properties, and a large number of them now. And Dr. Christine Jones, who's been doing most of the benchmarking on humus building, has shown that that is the single most effective grazing tool to raise humus substantially in quite a short time. It really is the best way to do it because you've left the solar panel that builds the humus. So that seems to be the strategy. The response to your question about the soils that have had, that were forest soils where there was that constant recycling of the forest debris, and whether there's any chance of rescuing those soils. From a grazing perspective, the same thing applies. Alan Savory, if you check his YouTube clip, has had tremendous results, and there are many organisations that are linked to his and similar type of organisations globally that have been basically taking arid regions and bringing them back with large numbers of livestock. You sort of can't believe it when you watch his video clips and he brings in 25,000 sheep into a total desert, and just that presence of those creatures with the biostimulation and so forth triggers the whole thing back into life again, and it really does seem to be a valid theory, a valid approach that you could use here, along with, as you mentioned, humic and fulvic acid, just so that you understand how important these minerals are. They are found naturally in humus. You make humic and fulvic acid when you make compost, and interestingly, they can be extracted from brown coal, and of course Australia is the worst CO2 polluter by far. We're actually twice the height of this building. If you were looking at a graph, there's China about this far behind the US, and we're twice as high as that building. We are horrific polluters of greenhouse gases with our brown coals. And those brown coals are the same thing, the same material that if we took, we've got one area called the Latrobe Valley where we take 750,000 tonnes of this material per week per power station, and there are 8 of them. So 5.5 million tonnes, and there's 120 years supply still there to use, but we can't obviously afford to. If we were to take that 5 million tonnes of that wonderful material and put it on the soil, we would transform our agriculture in a very, very short time. But the key is that we can pull those extracts out of the brown coal, and they're triggering mechanisms to regenerate. And you can use like 5-10 kilograms for $10-20 a hectare. So it's really achievable. They're the most powerful known stimulants of cellulose digesting fungi, which are the key creatures that build long-term humus in the soil and humates, and they will be like essential within the next 5 years. They have to be, because they're such important tools. And there's a lot of them available, and we can use our brown coals for that instead of burning them, and it's a much more valuable way to approach that. Thank you.
Well, thank you very much. Yes, Juan Carlos, please.
I have a question. One thing I missed was a more detailed set of policy recommendations. Have you done the numbers? Have you quantified, evaluated how much it would cost to implement some of your recommendations?
Well, as you've so ably pointed out, it really comes down to the farmers themselves and what's profitable for them. And the interesting thing is that they've been sold this story that they have to go down this industrial agriculture approach with increasing uses of chemicals. The findings and the real figure, and if we want to talk about sustainability, this chemical experiment, which is the last 10 decades, is it ongoing? Well, every year, and you can check these figures, every year since we started this experiment, we've increased our use of chemicals. And every year since we started this experiment, there's been more pest and disease pressure. It's actually literally the definition of unsustainable. You can't put more and more on for less and less response and poison your children into the bargain and call that sustainable. It is not the approach. And so what we've shown on a large scale globally, as I mentioned, an entire supermarket chain, all of their farmers farm this way, that it's doable, they make more profit, and of course there's far less costs in terms of chemical intervention. So you can sort of have your cake and eat it too, because this isn't just conventional organics where you did nothing and fell in a heap. I was in Europe talking to the key regulators of the EU, and they said organics has fallen in a heap in Europe because their levels they were getting 60% of the yield of conventional growers, now they're getting 40%. And I said, well, that's impossible. I wouldn't sleep at night if one of my organic growers got 40% of conventional. There's no reason at all that you shouldn't do the same, if not more. It's just a different road to Rome based on what you're allowed to use. And I started saying, are you doing soil tests? Are you doing leaf tests? Are you acting upon the leaf test? And they said, oh, no, you can't do that in organics. Organics needs to be a closed loop. And I said, what do you mean a closed loop? You're shipping off millions of tons of food filled with minerals. It's only a closed loop if you bury them back in the soil again. And they said, oh my goodness, they hadn't even thought of that. So I'm going back to train in Germany. It's this really heavily subscribed course of organic growers to train them with the basic things, the basic agronomy that they need to at least produce the same as conventional. There's no reason at all to produce less. That's old school organics. This is cutting edge new technology. It's based on soil and leaf testing and brewing up organisms and regenerating your soil and bringing in humates and understanding the role of core minerals that are totally neglected. No one even tests for molybdenum. Well, you don't get free nitrogen. The free gift, which is supposed to be where you get most of your nitrogen sustainably, you can't access if you don't have 0.5 of a part per million of molybdenum in your soil, and no one even tests for it. So there's a lot that needs to be taught. And when you learn those things, life changes.
Of more information, more research, that
everything
else.
It's a case of when growers embrace these approaches, it works, and that's the bottom line. So it works for them, and that can make the system change. From a government perspective, and the roles that a government can play, really, the change that has to happen quickly can be driven by, really it all comes back to money, as everything does. And I saw a wonderful example in Germany of Angela Merkel, who had really driven the nuclear power thing, and she was responsible for them being nuclear power delivering the vast majority of their power. Then, of course, after Fukushima, she brought together a group and said, oh my goodness, we are incredibly vulnerable, I've made a terrible mistake. So her example of how you change that was how we can, the governments, if they can take the initiative and recognises the imperative, how fast you can change that. And she said, okay, nuclear power, the power provider, the power retailers have to buy sustainably produced power. There's no choice on their behalf. And they pay 6 euro cents for nuclear power. They pay 8 euro cents for solar and wind power, and they pay 10 euro cents for biogas generation on farm, which is taking organic matter and to massive methane generators. And instantly, within 6 months, there are 13,000 of these massive biogenerators. It's the fastest, and that was just putting the money there so people went for it. And it's a tremendously sustainable concept that you could possibly even adopt here, biogas generation. And when you look at the logistics and the statistics on what the farmers are spending and what their return is, the actual return of 1.5 million euros for a biogas generator returns 1.4 million in the first year. It's a mind-bogglingly good way for farmers to make money. And the head of the German organic farmers has got one of these generators on his farm, and he had a PhD student do an entire thesis on whether he was losing carbon by taking 700 acres to produce the clovers that then made and they showed that the byproduct, which is all the minerals from the 700 acres, is a liquid that you put back out on the field, and you generate so much chlorophyll density from that massive amount of liquids that you actually build more carbon rather than lose it. So he used to do a lot of composting. This technique is actually building carbon on the soil and providing a tremendous source, and the government drove that, and it can happen quickly if you make it so there's money there for people to do things. Yes, thank you.
Thank you very much. We have 3 different groups of questions. I'm going to start with the first one. The first issue that I can recall is they would like to know, how do you think that big corporations could change the way they exploit the soil? They give us the example of Monsanto, with having in mind that they have to compete and that the commerce is a lot with the United States, and they have to still be thinking of that area. No? They have to compete, and still they could, if they could change the way that they exploit the soil.
It's a difficult question when we look at the whole genetic modified issue. I have studied it in depth. I've toured the world and talked about the issue. In my mind, there is absolutely no doubt that it's a premature technology that was really quite greed-driven and really doesn't give much back, certainly doesn't give much back to the soil. We now know that glyphosate, the world's most widely used chemical, and of course the predominant crops are these Roundup-ready crops, we now know that glyphosate is a horror show. It may well yet prove to be the most toxic chemical that we've ever introduced. When it was so-called biodegradable, it biodegrades to a secondary substance that lasts for much, much longer than anyone thought. We've seen a research by Professor Don Huber with many, many published papers now that have really just uncovered, really lifted the plug on this entire, almost a scam. We've now found in the last 2 years that glyphosate is a horror show for human health, and that there was lobbying to change what was previously decided as the minimum residue levels of glyphosate. You had to change that because you're spraying all your food crops with the stuff. So they changed and increased 50-fold what they took decades to decide was the right amount, the maximum amount. And so, and throughout America and Europe, there's been this complete change on what is allowable. And now we know from this last 18 months of studies that glyphosate is really, really bad for human health. And there are massive residues remaining on the food that's grown with Roundup sprayed all over the food crop. Is not a technology that any country should be looking at. And it's a sunset technology in my mind because it's not sustainable. And the chickens have come home to roost.
The second issue we have a lot of questions about is how do you do compost at home? How do you teach people to do compost at home? And would having a lot of people doing compost at home really make a difference eventually?
Yes, it's a good question, and yes, of all the things that you can do individually, if you look at the concept of turning off your lights and doing whatever you might want to do, because greenhouse gas production is all about energy, your contribution, if you've got some soil, any soil that you can work with, your contribution in building the organic matter in that soil through composting is by far the largest single contribution you can make as an individual, and all the figures are there. We talk about greenhouse gas emissions. Now, here's something you need to understand. If we were to cut greenhouse gas emissions, if we were to cut emissions is the only way we've been looking at managing this issue. If we were to cut 100% tomorrow morning, we're never going to do it. But if we did, what happens? Well, in 200 years' time, we're down to the levels of CO2 in the atmosphere that we had in 1975, which is still too high. The oceans continue to heat, the oceans continue to acidify, and there isn't an expert on the globe that would tell you we've got 200 years left. So that idea, at its most extreme, not saying we shouldn't cut emissions, but it doesn't actually save the day. The only thing that can save the day is either complete economic collapse, which slows it down, or building humus in our soils. And the figures, so that you know, 1.6% increase in humus globally pulls that 400 back to 300, which is eminently livable. Everyone's talking about we can't get beyond 350, and we've got 350.org and so forth. That 1.6% globally is the figure that brings us back there. So it is actually doable. The earth is savable, but we've got to recognise that the soil is the key, and humus is the key, and humus literally does save the world in this instance. So composting at home is really, you take your lawn clippings, you take your prunings, you take basically what we call levels of carbon and nitrogen. So you have brown material and green material, and you make your first layer of green material. And if you've got some pre-existing compost, or you can buy some compost for a store, you might sprinkle a little bit on that first layer and water it. And you sprinkle a little bit of lime as one of the key concepts, which you can also buy at a garden store. Then you make your next layer of brown material, and you water that, and that might be hay or straw or whatever. And then your next level of green and your next level of brown, each level watered in, each level sprinkled with lime, and preferably some pre-existing compost. Once you've made your first, you'll always have some to use to inoculate that compost. And once you've got your freestanding pile, whatever scale it is on a home level, then you might throw a sack or whatever over it and put your hand into it, make sure it stays moist while the composting process progresses. And at the end of 3 to 6 months, you've got this beautiful black, sweet-smelling humus that changes totally your soil structure and the taste of your food and the quality of your food as the ultimate wellness tool.
Thank you very much. And this would be the last series of questions. There are a lot of questions about genetically modified seeds. What would your thoughts be on that issue? The genetically modified seeds.
Well, that is the issue that I mentioned earlier, that it is a greed-driven premature. There is no, when you analyse the scenario, like the use of the Roundup Ready crops, did that reduce total chemical use? No, it didn't. Did any of the GM BT crops, where you take the genes from a bacteria that produces a toxin that kills little caterpillars that eat corn, and you splice that in so the corn emits this poison constantly. I mean, when you think it through, you think, oh my goodness, you know how nature works, you know how insects build resistance. When you took the spray originally of that bacteria, it lived for a week and it stopped the problem. It was a really widely used pesticide. But now the plant spews out that toxin, which is 10 times more powerful and is built up to 20 times more powerful now than the original toxin, and that's all day, 24/7. And insects are it's killing a lot of beneficial insects we now know, including the monarch butterfly, but insects are developing resistance, and they're increasing the strength for the resistance because it's there all the time, and that's how resistance works. So it's not sustainable. Smothering our food crops in Roundup. It's not sustainable building a toxin into the food we eat. As I said, it's about controlling the world's food by controlling the seeds. And we need to fight against that, in my opinion, as hard as we can fight. Thank you.
Well, thank you very much for this conference. A lot of students started leaving because we were a little over the time, but we're very happy of having you here. It was a very interesting, so if we could... We are giving on behalf of our rector a small present. And thank you for being here, and thank you all also for your interest.